Welcome back, guys. So in our first class we talked about how first principle derivation for calculus works, right? And in this video we'll try and see the proof how if y is equals to x raised to the power n, how we're able to derive the y over dx to give us this formula. That's what we're doing. I've given you the steps. I said there are 4 basic steps, right, to deriving first principle, right? The first step was to create. Okay, let's just take let's just do a simple equation. Let's take, for instance, following the steps, right? Let's assume we have y is equal to x raised to the power 2 plus 4. Let's assume we are using first principle. Using first principle, let's differentiate this, right? I said number 1, we create 2 equations. I replace equation 2 with this. So let's call this our equation 1. And then our equation 2, we are replacing y with y plus delta y, right? So equation 2, we have y plus delta y is equal to, we're seeing x squared here, x plus delta x all squared plus 4. That's our equation 2. That's what we said, right? So look at this now. We replace that. Steps 2 is to subtract equation 1 from equation 2, right? And then we expand. That's what I said. So if this is our equation 1, we subtract it from equation 2. So our step 2, we said equation 2, which is what? Y plus delta y minus y, equation 1, right, is equal to what? Equation 2, which is all of this. That's x plus what? Delta x all squared plus 4, right, minus x squared plus 4. We have minus what? X squared plus 4, right? So this is our equation 2 and equation 1. That's what I told you in the previous video, right? And then we expand. What we do is to expand this guy here, right? How do we expand this now? First of all, we know that y will take off y. We're left with delta y. So with that, we have that our delta y is equal to, by expanding this, I said we take the x square here, we square x, which is x squared, right? 2 times x times the x, we have 2x delta x, right? And then plus what? We take the square of this. That gives us what? Delta x all squared. That's how to expand this, right? Like we're going to be treating this in binomial theorem shortly. And then we have plus 4 minus, now minus times invisible plus here is minus, so we have minus x squared. In this case, we are using the minus to factorize the bracket. So minus times plus gives us minus x squared. Minus times plus gives us what? Minus 4. So what happens? We cancel. That's what we did. We cancel that next. Look at x squared. We take off minus x squared. So this and this are gone. Also plus 4. We take out minus 4. So this and this are gone. Right? That's what step 2 talked about. Step 3. Let's rearrange first before we do the step 3. So our delta y gives us what? 2x delta x, right? Plus what? Plus delta x all squared. That's what's left. Haven't done that. Look at step 3. Step 3 said divide both sides by delta x. So we are dividing step 3. Step 3, we are dividing both sides by delta x. So here we have delta x. Here we have, that's change in x. Either we call this delta x or change in x. And here we have our change in x. So what happens? We cancel out the delta x or change in x. We cancel change in x here. Also change in x. We cancel 1 from here. We're left with 1. What would that give us? Our answer therefore becomes change in y over change in x is equal to what? 2x, because we've taken this guy out, so we're left with 2x. 2x plus what? Plus delta x raised to the power of 1. That's delta x raised to the power of 1. Right? What else are we left with? Step 4 say we implement the limit function, right? We start implementing. So we are applying step 4. Step 4 said what? We invoke the limit, right? The limit condition, which said that we are limiting our delta x to 0 for what? Change in y over change in x, which will give us our dy over dx. So what does that mean? It means that wherever we see delta x, we fix in 0. That's what we talked about, right? So in doing that, we're going to have 2x plus, this is delta x now, so we're fixing 0 there. It means that this one is gone. What does that simply mean? It means that our dy over dx is equal to what? to 2x if we derive them using first principle. This is what is going to give us our answer. And that's what we're talking about. We said if we use first principle, which is the longer method to get this, there is a simpler formula, which is what? dy over dx, giving us what? Value of the n. So if we have this, using the shortest principle, using our small formula or the general formula, we say that if y is equal to x squared plus 4, our dy over dx becomes what? Whatever we have here, we multiply it here. That's the 2 and then the x. The same 2, subtract 1 from 2. 2 minus 1 and then plus what? The 4 is a constant number, it becomes 0. We don't have time, I will have shown you how this got to 0. But because of time, we know that the constant number 4 will give us 0. It's gone. So what happens now? Our dy over dx simply becomes 2x. 2 minus 1 is 1. That means dy over dx is equal to 2x. Now the same answer we got for this is the same answer we're getting here. We want to see how we can use binomial theorem using these steps to prove that if y is equal to x raised to power n, if we expand by binomial theorem, we're going to get this. So this is just an overview to show you how this came about. I'm going to take the board off and we start the proving. I'll see you shortly, guys. Thank you. Before we get to the proving, let me show you how to expand factors. Let's assume that we have